Hello guys, welcome to Python and Machine Learning Daily. Today we'll have a crash course on Pandas library in Python in one Jupyter notebook, which I will release on GitHub and put the link in the description below. Basically, all you need to know, the main things you need to know with examples. Typical use cases for that are any data manipulation projects. For example, you get the CSV from somewhere, you need to transform it and save it in a different format or somewhere else. Or you are working on a machine learning project and you need to have data input transformed and processed before building your model. A must learn for everyone. So let's go. As I said, we're working with Jupyter Notebook divided into topics with examples. So it will be something like this, 13 topics. One by one. Topic number one is reading the data from CSV, for example, or from somewhere into Pandas data frame. Data frame is the main kind of data type of Pandas. I personally call it like a mini database that allows you to perform various manipulations. You will see it practically in a minute. So to use Pandas in the first place, we need to import pandas SPD. Before that, we need to run pip install pandas, and then you're good to go. So we're reading the CSV file, police data, which I found on Kaggle. This is the CSV file, 9 megabytes of data. So from 2005 to 2015, from what I remember, who was stopped by police and what happened. And this is the original source. It's even called Pandas practices. So to download that CSV into data frame, you have pd.readCSV with just the file name. And then you call df variable head method. df is a short for data frame. So if we execute that in Jupyter Notebook, we have our data in a data frame, and that's why I called it kind of like a mini database. You have column names and row numbers starting from 0. This one is called index. And df head is the first example how you can explore the data to see the main things about it. For example, you can do head 3 to see first 3 lines, and then the opposite is tail. You can see the last lines. Then also there are various helpful methods for other kinds of overview. For example, shape. Shape is not a method, it's a property which will show you the size, this many rows and this many columns in the data frame. Then also there's info, which will show the columns, and important thing, how many rows of that column are non-null. Have data, which means, for example, stop time and stop date are always with data, the same number as amount of entries. For example, gender sometimes may be null, and then the 0 means that this column is always empty, basically meaningless. And also that info shows the data types, and we will get to that later in the video, and memory usage, which is 9 megabytes. Also, while reading CSV, you have a lot of parameters. For example, you may read only some columns that you want. If we execute that, we have the data frame with only 3 columns. So this is how you read the data from CSV into Pandas data frame. You can also read from other sources. This is topic number 2. There are a lot of functions of PD read something like JSON, HTML, Excel, and stuff like that. For example, we have JSON file like this, and we can do PD read JSON into data frame like this. So this is how you create the data frame from external source like CSV or Excel or stuff like that. But sometimes you may want to create the data frame from your internal variable in Python like list or set. And here we have 2 examples. For example, you have 3 names, 3 ages, and 3 income, and you want to combine that into a set first, and then you can create a data frame with pd.dataframe providing that set. And this is the result. Or for example, if you have a list of lists this way, you can just do pd data frame and assign the column names, and this is the result. The same basically result is just from different data set. So this is how you create the Pandas data frame, but also the other way around. You can use the data frame to store the data somewhere, and this is very easy. It's just to something. You have data frame, and for example, to CSV, to JSON, or to whatever. If we execute that, we have the same JSON structure that I showed a minute ago, just saved as CSV with this line. Now, enough about input and output. What can we actually do with that data in the data frame? One of the most common usages is locating the records, slicing the records by indexing, which is done with iloc. iloc stands for index location, and there are various syntax ways to do that. Let me show you. So first, as a reminder, this is our data frame, the first 5 lines, And if we call index number 1, index starts with 0, I remind you, we will get this line. We execute and we have all the columns of row with index 1. Also, we can filter a few rows, for example, from row with index 1 to index 3. The result will be 1 and 2, excluding that last one of 3. And also, after comma, we may provide second parameter, which is columns. So those two rows with only column number 1, which is, again, index starts from 0. The result is these timestamps. Also, there is negative value possible, which means that it starts from the last column or last row. The result will be false, false, which is the last columns in this data frame. Drugs-related stop. And both with rows and columns, you may provide range. So the result of that one will be index 1 and 2 on the left and index 1 and 2 in the columns as well. Also, if you don't provide any numbers, it will mean all the records. So give us all the rows, but only those columns. This is the result. All the rows, 91,000, with just those two columns. Similarly, you may provide -1 here, and this is a typical use case, by the way, in machine learning projects. Get all the rows with all the columns except the last one, and then separately, the predicted result may be in the last column, so that's all we need. And we get that column value with this syntax. It may sound quite overwhelming, but with practice you will get used to various syntax options of iLog, which is very common to use in real projects. Next, we can filter the data in our data frame, mostly with two syntax ways. There are more than that, but in this video I will stop on main use cases and main things you need to know. So for example, if you want to filter only gender female, this is the result. As you can see, the column driver gender is only F. Another syntax example is with more than one condition. Then you put them into brackets and then you'll have F with driver age up to 21 years. Another syntax option is call some function on specific column. For example, violation row, which is a string column, this one. What if we have speeding or maybe others containing speed? We execute that and we have 3,000 rows from that. And then finally, alternative syntax, especially if you have more complex query filter, you can provide df query and a string with list of your conditions. So this is how you filter the data with brackets filter or df query. Next operation often performed on dataset on data frame is cleaning. What if there are empty values which we don't actually need for processing? So first, how do we check for that? How do we calculate if there are any values? This is the syntax. Is an A, which is the same as is null, and with sum you calculate how many rows per column are with empty values. So some of the columns have 0 empty values, which is great, but others not so great, and then we decide what do we do with those columns. The most simple thing is drop an A, which is drop everything that is null. So I remind you, we have 91,000 rows, and if we execute drop NA, we will have 0 rows because it will drop basically everything, because one of the columns has empty values for all the rows. So instead we probably should drop rows if some specific column is empty, for example stop outcome, and then we'll have 86,000 rows, so roughly 5,000 were dropped. And now if we execute that again, as you can see, stop outcome now has 0 and more columns are automatically 0, which apparently was correlated. Now, important thing, also drop NA we will execute on driver age, for example, because we have 200 rows. But in other tutorials, you may see this syntax of drop NA, and then instead of assigning that to a new variable, some developers do in place true, which is a syntax in Pandas, but it will be deprecated with Pandas 3 at the time of shooting this video. And some developers do not recommend to do it because you may unintentionally override the original data frame and lose all the changes that you did before. So I just show that as syntax that you probably should not use. Instead, after some operation, assign that to the variable, which may be the same variable if you know what you're doing, but it may be also a different variable. So if we execute that, a few more lines are filtered, so 293. And then also we can not only drop the values, but replace them with something else. For example, we have 2 rows with driver gender empty. let's replace that with M by default, and for that you use a function called fill_NA. If we execute that, now we have 0 rows with empty columns except for those 2, which then you choose what to do with them, and we will get to dropping the columns in a minute. For now, let's continue on dropping the rows and cleaning the rows with another case of duplicates. So there may be not just rows with null values in the columns, but also identical rows. And this is how we filter those. df duplicated, and we will see what keep means. If we execute that, we will have, as you can see, 2 identical rows with all the columns with the same value, but with different index numbers. And if you provide that keep false, it will show both records, but if you don't provide it, it will show only the last one or the first one, it depends. You can provide keep last, keep first, or false. But for the demonstration, I wanted to show you keep false, so you will see both records. But this is just the information. We haven't changed anything yet. If you want to change the duplicate, then you call drop duplicates. Or for example, if you want to identify the duplicates only by certain columns, you may identify those, and then you have more values. For example, these 2 lines are not fully identical, but identical in terms of stop date and stop time, but some other columns have different values. So yeah, if you want to clean those, in this case drop duplicates on fully duplicate values of rows, we have df cleaned with 91,200 rows. And now we're getting to topic 9, cleaning the values by column values. For example, you may want to disregard some column values if you are not interested in that type of data. It may be not necessarily null values or empty values. For example, if you run value counts on certain column, it will provide you with statistics of how many values, different values, are in that column. So there are different violations, and this function also helps you to identify the most popular cases. It's not just for data cleaning, it's more like for overview as well. But in this case, for example, if we do value counts on stop outcome, we may identify that there are ND and no action, and we may want to disregard them and not include into the actual data frame for analysis. So in the original data frame shape, we have 91,000 rows, and we may filter them with another syntax option. I will show you. So column is in, and then list of values, and then this means negative. So stop outcome is not in those values. And we filter that, and the result is around 1,000 rows fewer. Topic 10 is the columns. What if you want to drop a certain column, like for example, we have county name, which is meaningless and irrelevant. As a reminder, we have data frame head, and this is NaN in all the rows. And as a reminder, we show that all the rows are empty for that column. So we just drop it. df drop, you provide column name, and you provide axis 1, meaning that you're dropping the column, not the row. And then the result is this without that column. Also, you may rename the columns. For example, I saw that the column driver age row is actually not what it means. It means birth year. So let's rename that. And also I noticed that there's is arrested Boolean value, and I like is prefix for Boolean values, but it's not used here. So search conducted, true or false, and then drugs related stop, true or false. So let's add is prefix to both of them. And we provide dictionary before value, after value, and this is our new head with new is search conducted and is drug related stop. Also, you can create new columns calculating the values from existing columns. For example, like this. We import the date time to get current year to calculate the current age of that driver, not at the time of having that CSV. So we have a new column, the last one, driver age current. But also you may want to have that in the beginning, not at the end of data frame. For that you would do insert with index of the column, in this case 0, new column name, and then the formula. We execute that, and then we have driver age now, which is the same of the value of driver age current. I just showed you how to add that in the beginning. You may also update the values on some columns with more or less complicated functions. For example, you may assign driver gender with driver gender and then apply a function, which may be a function name outside somewhere in Python, or inline callback, so-called lambda function of Python. For example, you want to have words male and female instead of first letters. So if we execute that, we have male and female here, updated column value. Next topic is data types, and specifically we will talk about date time as an example. If you execute info on your data frame, we already saw that in the very beginning, and I told you that we will come back to that. You have data type column. So these are objects and these are floats, for example, and these are Boolean values automatically detected by Pandas in a data frame. And this may be not important in some cases, but if you want to perform some operations related to that specific type, you may have issues if you don't convert the data types. And date time is a perfect example of that. For example, we have object on stop date, and what if you want to have a column stop year? So get the year value from that stop date. If you want to do that just like that, like something dot year, it would fail because there's no year value on stop date. It's an object. Object has no attribute of year. So you need to convert PD, pandas, to date time and specific column. Then if you perform the conversion, then that column becomes date time, and then you have additional capabilities like .dt .year. Let's execute that with commented out insert, and this is the result. Info gives date time 64, and then no error below, and we can do df head and see, oh, there's error because there's already a column, so I don't need to execute that again. So yeah, we have stop year, and stop year is the correct value. But also you may perform that conversion operation while reading the CSV. Parse dates parameter in read CSV, and you may specify the column names, which should be automatically converted to date time. If we execute that, then stop date is date time already immediately automatically, and then you can use dt year freely like this. The next topic, we have two topics left, is index. In some cases you don't really care about the index, but there may be cases where that index may be important. So as a reminder, we can filter the values and gender is F, but look at these numbers on the left. The index numbers are not anymore in sequence. So there's no 0, 1, 2 and others. There are 4, 7, 11 and others. And then if you execute ilog here, these numbers are not the same as these on the left. And that may be important in some cases where you rely on index numbers or index values. And by the way, index not necessarily are numbers. You may provide your own index, but that is kind of outside of topic of this video. I would assign that to more advanced topics of pandas. In this video, I want to focus on crash course. But anyway, if you want to reset that index, this is the syntax, reset index, and drop true is needed. Otherwise, it creates a new column called index, which in most cases we don't want to do. So we execute that, and then we have the same filtered rows, but with reset index value. And then final topic, what we can do with that data after all those operations. So we filter the data, clean that up, drop some columns, drop some rows, and then we can finally do some calculations, modeling, transformation, and whatever you want with that data. Like, for example, sorting the values, ascending or descending. So you execute that, and you have driver age from 15, or you can do it ascending false, and then driver age from 99 descending. Also, you can calculate the average values, which is mean, on some columns grouped by other column. Let me demonstrate. This is arrested false or true, so arrested people were a bit younger. And then finally, data frames pandas have plotting functionality. So if you want to, for example, calculate the age average by year and then have plot, we execute that and we have plot visual, years and then driver ages. And plotting in pandas with extra libraries on top is a totally separate topic, which we'll probably cover in the future videos, but I just wanted to show you one of the functionalities of Pandas library. So that's it, kind of a crash course, what you really need to know, main operations on data frames. If there's anything I missed or something was incorrect, let's discuss in the comments below. And if you have more ideas for such crash course topics that I should summarize on this channel, also use the comment section below. And this Jupyter notebook will be on GitHub. I will put the link in the description below. That's it for this time, and see you guys in another video.